Hi students, this is Professor Gina and I am making a video for Thursday talking about finding the surface area of pyramids and cones. So the first thing we need to do is talk about some of the terminology. And so the first picture that I have is just a generic pyramid. It has a square base. Remember that the base is the shape that is sitting on the table, and so the base in this first example, is a square. The height of the figure, which is labeled as H, it's right here, is going from the center of the base. If there were a point right in the center, going up to the very top, we call the top of this the apex. And then it's kind of hard to read, but this letter, I'm going to erase the red that I drew there. This red line that's coming down the side, it's actually on one of the faces of the triangle. It's labeled as the letter L, and it stands for the slant height. It's different than the height of the pyramid. The height of the pyramid is going from the base up to the very top. The slant height is going down one of the sides. And you'll see why we need that in just a minute, because it's related to finding the area of those side triangles. So I'm going to draw the net of this pyramid that we have here. The net would be a square, and then we've got 4 triangles that are all, in this case, the same size, right? And so the surface area is going to be the area of the base shape, in this case it's a square, plus 4 triangles. And the area of each triangle is, so the area of one triangle is 1/2 little b for the base, or the base meaning this side here, right? Times the height. The height in this case is this. But in the way that we've drawn the pyramid, the base is actually the length of one of the sides, right? It's this. This becomes the base of the triangle. So really, we're going to have 1/2 s, and then the height is instead the slant height, so it's going to be L. And for this particular triangle, we have 4, or for this pyramid, we have 4 triangles. So the area of the total surface area is going to be the base, capital B, it's going to be a square in this case, plus 4 times 1/2 the length of one side times the slant height. If I take the 4 and the length of the sides and put that together, that's the same as the perimeter. So the general formula that we're going to use for surface area of a pyramid is the base plus 1/2 the perimeter times the slant height. So this will be surface area of a pyramid. The pyramids that we're going to be talking about are going to have regular shapes as their bases. So this is the formula that we're going to use. Okay, let me pause for a second so I can move some of these things down because I'm running out of room here. Give me 1 second. Okay, I'm back. I just wanted to move that pyramid down so we have more room. So we're going to use this formula to find the surface area of, here we have a triangular pyramid. The base is, even though it looks a little bit skewed, the base is supposed to be an equilateral triangle. We know that because there are 3 tick marks on each of the sides of the base. And and the height, or the slant height there is 6 centimeters. So if we have an equilateral triangle, let's do this. We're going to first figure out what the area of the base is. The base is an equilateral triangle, and each side is 4 centimeters, right? So if I were to make a line here, which is the height of that triangle, this part would be 2 centimeters. And so we need to figure out the height here of the base shape. So we can use the Pythagorean theorem for that. We'll say that h squared plus 2 squared equals 4 squared. Subtract 4 from both sides, so h squared is equal to 12. And then if we take the square root of both sides, we get that h is equal to the square root of 12. Or we can simplify that into 2 times the square root of 3. Okay. So now we can find the area of that triangle, which is the base. The area of the base is 1/2. When we talk about the base of this, we're going to take this whole side, which is 4. And the height is 2 times the square root of 3. That 1/2 and the 2 will cancel each other. And we're going to have that the area of the base is 4 times the square root of 3. Then what we're going to do, going back up to our formula, to find all of the triangular sides together, we're going to take 1/2, the slant height, times the perimeter of the base. So all of the sides together is 1/2 the perimeter times the slant height, or 1/2. The perimeter is 4 plus 4 plus 4, which is 12, and the slant height is 6. And so this is going to end up being 36. So it looks like our total surface area is the base plus 1/2 the perimeter times the slant height, or 4 square root 3 plus 36. We can't combine those two because they're not like terms. And the units for this is in centimeters squared. So that is the surface area for that triangular prism. The next example is a square prism, but we're going to follow the same process. We're going to find the surface area by finding the area of the base shape and then taking 1/2 the perimeter times the slant height for all of the side. There are 4 side triangles together. The area of the base is 25 times 25, right? So 25 squared. The perimeter of the shape is going to be 25 4 times going around the base, so that'll be 100. And then the slant height is 32. So grab my calculator. 25 squared is 625. And then I've got 50 times 32, which is 1600. And so my total is 2,225, in this case, square feet. That's our surface area for this square pyramid. Okay. I have a couple different examples here. In this example, the pyramid is made up of a rectangular base, and so the 4 triangles are not going to be the same length. So in this particular case, the formula that we used before is not going to work. So we're going to take a different strategy. I'll start by drawing the net of this. So I've got a rectangle. I've got 2 skinny triangles on this side, and then I've got 2 more wide triangles on these sides, right? Now, it's a little bit different to figure out what the lengths of all of these things are. I know that this side here is 6, and I know that the height of the triangle is 14, the internal height. I know that this distance here is half of 13, right? And so if I want to figure out the slant height of this little triangle that's on the side, I've got to think about this triangle here that's on the side where it's 6.5 for the base, that's half of 13, 14 here, and I want to figure out what this is because that's going to end up being the height of this triangle. And then also this triangle as well, because those two are the same. So I'll use the Pythagorean theorem. I'm going to say that L is going to be the square root of 14 squared plus 6.5 squared. Which is about, is about 15.4. Okay. So these two small triangles are 15.4 for the height and 6 for the base. So the area of two small triangles is 2 times 1/2 times 6 times 15.4. So that's going to be 92.4. That's the area of the two small triangles. Okay. We're going to follow that same process for the larger triangles. This time, we're going to look at a different slant height. We're looking at a triangle that is coming out this way. That length is 3. And then the slant height, it's kind of hard to draw, comes in the front face here. So I'll draw the triangle over here. That triangle looks like this. The height of it is still 14. The side of it is 3, and we're trying to find this slant height, a different slant height, right? So again, we can use the Pythagorean theorem, and we can say that that is going to be the square root of 14 squared plus 3 squared. So let's see, 14 squared plus 3 squared is about 14.3. So then the area of two large triangles is 2 times 1/2. The base of that triangle is 13. And the height of that triangle we just found to be 14.3. So that's going to be 14.3, 185.9. Okay. So then the total surface area is going to be the area of the rectangular base. The rectangular base is 13 by 6, right? 13 by 6 is 78. That's the rectangle. And then we have 92.4, which is the two small triangles. And then we have 185.9, which are the large triangles. 78 plus 92.4 plus 185.9 is, I'm getting 356.3. square centimeters. Okay. All right, I have another example on this slide, which is a pentagonal pyramid. It was kind of hard to get some of the lengths on this pyramid, so I just wrote them below. So each side is going to be 4 inches. So 4 would be one of the sides of the pyramid. We have the apothem. Remember, the apothem is the part that comes into the center here, and that's 2.75 inches. We'll need that to find the area of the base pentagon. And then the slant height, which is over here on the side of one of the triangles, is 9 inches. There will be 5 triangles that are identical to this, so we can use the formula that we had before, that our surface area is going to be the area of the base shape plus 1/2 the perimeter of the base times the slant height. That'll grab all 5 triangles at the same time. So let's focus on the base shape first. A pentagon is made up of 5 different triangles, but those 5 triangles are not equilateral. So what we have to do is figure out the area of one of them. And luckily we've been given the length of the apothem, because that helps us. We know that this is 2.75. And we know that this is 4. So the area of the base is going to be 5 triangles. They're each going to be 1/2. The base of each triangle is 4. And the height of each triangle is 2.75. Let's multiply that together. 5. I'm getting that this is 27.5. So that gives us the pentagon. Then for all the sides, we're going to have 1/2. The perimeter is 5 times, right, going around. So that's going to be 20. And then the slant height was 9. So this is going to be 90. So I think that the total surface area is the base, 27.5, plus all the sides together, which is 117.5. And our units are inches square inches. Okay, let's look at a couple of cones, which are really similar to pyramids. The only difference with a cone is that the base shape is a circle, and you can see in this one here, we've got the the radius, which is going to help us find the area of the base, which is a circle. We still have a height, which is internal, going from the center of the circle up to the apex or the top of the cone. And then we also have the slant height still on the side. And I'm going to show you how the formula for pyramid and for cone are similar. So the surface area of a pyramid is the base plus 1/2 the perimeter of the shape times the slant height. The surface area of a cone, well, for a cone, the base shape is a circle. and the area of a circle is pi r squared. And we still have the 1/2. The perimeter of a circle is called the circumference, and it's usually pi times the diameter. And the slant height is still the slant height. Now, if I think about 1/2 of the diameter, that's the same as the radius. So often what you'll see is the formula written as pi r squared, that's for the base, plus pi times r times L. What I did was combined the 1/2 and the d together to just be a radius instead. So this is the formula that we're going to use for the surface area of a cone. And we'll do, oh, that's weird. We'll do a couple examples down here. So I think I have 2. Okay. So in this example, I have the diameter and I have the slant height. Make sure when you're looking at these pictures that the slant height is the one, it's always kind of on the outside. The actual height will be in the internal. We'll need to have that internal height for next week when we find volumes. So for this example, we'll use the formula that we have. So our surface area is going to be pi times the radius squared. The radius is 14 in this case, right? Because it's half of 28, plus pi times the radius, which is 14, and the slant height is 50. For these examples, I'm going to leave the pi symbol to show the exact answer, and then I'll estimate for an approximate answer so you can see the difference. So 14 squared is 196 times pi, and then 14 times 50 is 700 times pi. And so that would be 896 times pi. This is the exact answer. In elementary school, the kids don't use calculators very frequently, and so they're typically going to give the exact answer like this with the pi symbol left in it. If we wanted to get an approximate answer, then we would maybe type in 3.14 for the pi symbol. And so in this case, we'll get 896 times 3.14. I'm getting that the approximate answer is 2813.44. Oh, I forgot my units. It's going to be meters squared, right? This is the approximate answer because we've rounded pi. You'd have meters squared in here. So just make sure that you know how to get both of those answers. All right, let's do one more example. The surface area is going to be pi r squared plus pi times r times L. In this example, we have the diameter and we also have the height, but we don't have the slant height. So what we're going to do is consider a triangle that's kind of on the inside of the cone. It's looking like this. And we're going to figure out what the slant height is by using the Pythagorean theorem. This is 15. I said 15 and wrote 6. This is 15. This is 6 because we're cutting the diameter in half. And so then we've got to figure out the slant height. So the slant height is going to be the square root of 15 squared plus 6 squared. And that is approximately 16.2. All right, so for the surface area, I have pi times 6 squared, because 6 is the radius, plus pi times 6 times 16.2. So this is 36 pi, 16.2 times 6 is 97.2 times pi. So this is 133.2 times pi centimeters squared, and this is the exact answer. Well, not really. This isn't really an exact answer because down here, I already estimated the slant height. So in this case, we'll just go that these are both going to be two approximate answers. This one's just got the pi symbol left in it. It's also an approximate answer. But if I multiply that by 3.14, I get 418.248 centimeters squared. So either of those answers would be fine in this case. One's got the pi symbol and one doesn't. All right, that is it for this video. Next week, we're going to take these same shapes and find the volume of them. Have a great weekend, and if you have questions, send me an email. All right.